Mean, the average mode, most often range. Subtract the smallest from the largest. Median, the middle number when you line them from the greatest to the least. Mean, the average mode, most often range. Subtract the smallest from the largest. Median, the middle number when you
I'm hoping I'm right
line
that
them
solving
from the
algebraic
greatest
equations
to
like
the
this one will
least.
be some of the easiest problems on this test. I say that because we had a lot of time before the break to work on this, and you guys got really good at this. So it's just a matter of remembering what we did and just refreshing your memory and doing a little practice. So in order to solve this equation, I need to isolate the variable n on one side of the equation. I'm just going to rewrite the equation. N minus 3 equals negative 7. And as I do this, I'm going to talk about the different properties. You don't have to write a proof. In other words, you don't need to cite each property as you use it, but it's good to talk about them because I do expect you to know what the properties are when you take the test. You'll be tested on that by answering some questions about different properties. So here we have n minus 3 equals negative 7. We need to, some of you like drawing the line down the equal sign, so if you like doing that, you can do that now. We have two sides of the equation. They're balanced. It's just like a balanced scale. So I can do anything I want to one side of the equation as long as I do the same thing to the other side to keep it balanced, and that's called property of equality. What I'd like to do here on the left side of the equation, the side with the variable, is to undo this subtracting 3. I use the inverse operation, which is adding 3, because negative 3 plus 3 is 0, and if I have n plus 0, I have n. I know what n is. So if I add 3 to the left side of the equation, I have to add 3 to the right side of the equation. Again, that's property of equality. Negative 7 plus 3 is negative 4. And on the left side, this constant term is now 0, so I don't need to write it, but I still have n. So n equals negative 4. So that's the solution. N is negative 4. But we need to check it by substituting it back into the original equation. Rewrite the original equation, n minus 3 equals negative 7. So if n is really negative 4, then negative 4 minus 3 should be negative 7. We know subtracting is the same as adding the opposite. So negative 4 minus 3 is the same as negative 4 plus the opposite of 3, which is negative 3. And negative 4 plus 3 is negative 7. So negative 7 equals negative 7. When we're verifying a solution, we rewrite the original equation. Then we use the property called substitution to substitute n for its equivalent value. So that's substitution. And then in the end, when we get negative 7 equals negative 7, that's called the reflexive property. It's like negative 7 is looking at its reflection in the mirror. Over here, when we added opposites to get a sum of 0, that was the additive inverse. Okay, problem 6 on page 2. We're solving another equation. Here we have r. Oops. Here we have r divided by negative 7. The vinculum indicates division. Is equal to negative 4. Again, if you like showing the two sides of the equation, you can draw a vertical line down the equal sign. I'm going to always focus on the side of the equation that has the variable, and so I'm focused on the left side in this case. And I have to think about how do I undo dividing by negative 7? What's the inverse operation for dividing by negative 7? It would be multiplying by negative 7. Because if I multiply this fraction by negative 7, if I think of negative 7 as a fraction itself, negative 7 over 1, I see that these negative 7's cancel and I'll just get 1r. That's what I want because 1r is r. But if I multiply the left side by negative 7, I need to multiply the right side by negative 7. That's property of equality. You can do anything to one side of the equation as long as I do the same thing to the other side. Negative 4 multiplied by negative 7 is positive 28 because a negative multiplied by a negative is positive. And over here we're multiplying reciprocals when we multiply negative 7 by 1 over negative 7, and that's the multiplicative inverse. I've used the inverse to get a product of 1 because these negative 7's cancel and I just get 1r, which is r. So r equals positive 28 if we did it right. we'll know when we use the substitution property by substituting 28 for r in the original equation. I'm going to substitute r for its equivalent value, 28. So 28 divided by -7 should equal -4. A positive divided by a negative is negative, and 28 divided by 7 is 4, so this is -4. So -4 equals -4, and again, that's the reflexive property. -4 equals -4. Problem number 7 on page 2 shows you a line plot showing daily rainfall for many days. Don't know how many days yet. That might be part of the problem. It asks, the first question asks, what is the range of the rainfall? So range is, remember the song, range subtract the smallest from the largest. So it's the high minus the low. And when you're looking at a line plot, the data is already organized from least to greatest because the data is plotted on a number line in order from least to greatest. And then wherever you see an X, that's a data point. So I had 3 days where it rained, it didn't rain at all, so 0 inches of rainfall. And then over here I had a day where it was 1.5 inches, a couple days where it's 1.7 inches of rainfall. So each one of these X's represents a piece of data. And the highest is 4.1. The lowest, of course, is 0. So 4.1 minus 0 is 4.1 for the range, 4.1 inches. Okay, what's the mode? This is a nice thing about line plots. You can easily find the mode. The mode is the data that occurs the most. And since these X's are stacked on top of each other, you can find the tallest column, which in this case is right here. And that's 1.2. So there were 4 days where it rained 1.2 inches. So 1.2 inches is the mode. The median would be the middle number. Now I circled the high before, so I'm going to circle the low. And then I'm going to keep circling the highest one that's left and the lowest one that's left. One high and one low, circling a high and a low in pairs, working my way toward the middle. Circle the high and the low. One high, one low. One high, one low. Keep doing that in pairs. Now the highest is right here, the highest that remains is right here, the lowest, the highest, the lowest, the next highest, the next lowest. And then I have 3 pairs, so I'm going to end up with a pair in the middle. These 2 are in the middle, and since this is 1.2 and this is 1.3, what's right in between 1.2 and 1.3? If you expanded that number line, the midpoint between these 2 would be 1.25. 1.25 inches, or 1 1/4 inches. Another way to get that is to add 1.2 plus 1.3. It's 2.5, and when you divide by 2, you'll get 1.25. It's the mean of those 2 numbers that are in the middle. The final question asks, on how many days did it rain more than 1 inch? So I'm going to box in, first of all it says more than 1 inch, so it wouldn't include these 2 days. But all of these other days that are more than 1 inch would be included, and so we just need to count the X's. I have 4 here, plus 3 more is 7, plus 3 more is 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 days. There were 19 days where it rained more than 1 inch. So that problem is just all about understanding how to interpret a line plot and how to use the data from a line plot to find mode, median, range, and understanding that each X represents 1 data point. The final problem on page 2, problem 8, asks you for an example of each of the mathematical properties listed below. So the multiplicative identity tells me that if I multiply by 1, the value maintains its identity. 7 multiplied by 1 is 7. Or you can another way to think about it, if you multiply by 1, you don't change the identity of the number you're multiplying by. And so that's really a valuable property when we're solving equations, because if we can change what we're multiplying or dividing by to 1, then we can start to isolate variables and solve equations. The multiplicative inverse tells me that if I multiply reciprocals, I get a product of 1. So 7 multiplied by 1/7 equals 1. Or 2/3 multiplied by 3/2 equals 1. I'm going to skip down here. The additive identity tells me that if I add 0, I don't change the identity. So 7 plus 0 is 7. And we use that, we work toward the additive identity to remove constant terms from one side of an equation using the additive inverse, which tells you if you add opposites, you get a sum of 0. The additive inverse is it tells you that if you add opposites, you get a sum of 0, and that's how we work toward the additive identity, by applying the additive inverse when we're solving equations. Substitution, so if I had an example like 2x equals 8, I could solve that and figure out that x equals 4, and then I could substitute that value back in to make sure it works. So 2 multiplied by 4 equals 8. When I go from this expression to this expression, I've substituted the equivalent value, and that's substitution. The reflexive property would be like if I completed this and I find the product 2 times 4 is 8, and then I write this line 8 equals 8. That's the reflexive property. That's like 8 is looking at its reflection in a mirror. And that's how you can check that your variable value is correct, by substituting back into the original equation and then working toward the reflexive property, or verifying that you do end up with the reflexive property. The property of equality, if I take that same very simple equation and I think about how I would solve it, in this case I don't want to know 2x, I want to know 1x, because 1x is x, and so I would undo this multiplying by 2 using the inverse operation, which would be dividing by 2. But if I divided the left side of the equation by 2, I would need to also divide the right side of the equation by 2. So that's an example of property of equality. If I do the same thing to both sides of the equation to keep the equation balanced, just like a balance scale, that's the property of equality. Okay, that completes page 2. We'll continue the review with page 3 on the next video.
Median, the middle number when you line them from the greatest to the least. Mean, the average mode, most often range, subtract the smallest from the largest. Median, the middle number when you line them from the greatest to the least.